Hello, everyone, and welcome to Applications Manager's free training series. First off, we'll be looking at how you can monitor your critical workloads and important KPIs in your Azure and AWS platform. We'll be looking at how you can gain insight into your Kubernetes clusters by monitoring your nodes, pods, and containers. Thirdly, we'll be looking at how you can detect, troubleshoot, and resolve the issues inside and outside your cloud environment. And finally, we'll be looking at how you can track the performance of your Microsoft Teams application. Before we go in depth about today's topics, let's take a look at the cloud in general. The cloud movement started garnering attention in the early 2010s and has grown exponentially ever since. As you may know, there are three types of clouds. One is the public cloud, the other one is the private cloud, and the third one is the hybrid cloud, which is a bit of both private and public cloud. In addition to these, you also have the community cloud and the federated cloud, which are all deployed as infrastructure as a service, platform as a service, and application as a service. In 2021, it was predicted that 90% of the enterprises would move to the cloud by 2022. But these predictions usually downplay the actual value to avoid overestimating, and we can see that 94% have already moved to the cloud. The market value was estimated to be around $445.3 billion in 2022, and is expected to grow annually at the rate of 16.9% to $832.1 billion in 2025. The market is growing rapidly, and if the pandemic and the subsequent remote work culture has taught us anything, it's how dependable the cloud actually is and how much we've grown to depend on it. If this trend continues, I expect the market value to cross $1 trillion by 2025. So why do people adopt the cloud model? One of the main reasons organizations are lining up to adopt a cloud strategy is how easy and quick it is to migrate to it. In traditional data storage methods, the amount of data stored is directly proportional to the physical space it occupies. But that's not the case with cloud storage. You can store any amount of data without worrying about how much you have to scale, not only virtually, but physically as well. This technology is also incredibly flexible. It allows you to scale new resources quickly, control workloads, and ensure a seamless end-user experience. It provides an easier and a more systematic approach to handling multiple workloads and disaster recovery scenarios. So even though the cloud offers a myriad of benefits, it comes with a few challenges such as difficulty in mapping dependencies, limited visibility into the cloud structures, and a lack of control. Cloud applications can be dependent on multiple clouds and on-premises technologies. It can be dependent on hundreds of elements, and discovering these elements is quite tricky. Some of these elements in the cloud architecture are complex, and the visibility into them is often minimum. And the lower the visibility, the lesser control you have over the output. Sometimes unscheduled downtime and increase in application latency can occur. Now consider this scenario. You want to perform an action which consumes a lot of data. This would make it both time intensive and complex. Now you want to perform another action which has to wait until the first action is fully executed, since it uses the same resources. This results in a deadlock situation, which causes the application to slow down. In a worst-case scenario, it may result in server crashes, thus causing downtime. Companies could lose millions along with their reputation if they encounter this situation. Since the visibility into the cloud structures is low, it becomes harder to troubleshoot and optimize the performance, unless a third party is involved. Now, this third party is the monitoring tool that helps you overcome these challenges. And that's exactly what Applications Manager does. As you may know, Applications Manager is an infrastructure and a server monitoring tool which also offers application performance monitoring on the side. It offers monitoring for over 150 technologies, including databases, cloud, server, and other infrastructure elements. It also automatically discovers these applications and maps their dependencies. Take a look at this flow diagram to understand how Applications Manager monitors the cloud apps or containers. So you have the cloud infrastructure in which you have the compute elements, containers, applications, and servers. And you also have the native monitors for all the cloud vendors like AWS, Microsoft Azure, Google Cloud Platform, and Oracle Cloud. Now, Applications Manager aggregates and collects these metrics and processes it into meaningful information that is both easy to understand and interpret. You can also use this information to associate thresholds to the KPIs and manage the faults, and also aggregate it over a period of time to analyze the historical trends and to forecast the resource usage and growth. An admin or a user can use the Applications Manager's desktop console to view all this data, or they can use the mobile app to view the data as well. Applications Manager monitors all the popular cloud technologies such as AWS, Microsoft Azure, Google Cloud, Oracle Cloud, and Microsoft 365, in addition to monitoring all the containers such as Kubernetes, Docker, and OpenShift. But today we'll be focusing only on the two most popular technologies, which are AWS and Azure. So first off, AWS. So Applications Manager collects the metrics for the Amazon Cloud Services through the Amazon CloudWatch. It makes use of the appropriate APIs for the different services to collect the data, which is then aggregated and compiled using AWS SDK. So the performance of a system can be defined in terms of the system's ability to perform a given task successfully. This performance, if the tasks are executed successfully, is measured by the time taken to perform the task, the rate at which the tasks are performed, and the resources consumed while performing the tasks. So when you monitor a particular service, these are the three parameters you need to monitor. And in general, the efficiency of a given system can be expressed in terms of performance. I'll reveal the metrics that you need to monitor to keep the services running and to ensure a steady performance in a short while. Before that, let's take a look at all the services monitored in Applications Manager. You might have gotten a rough idea about the services monitored from the previous slide. As you can see, you can monitor your compute elements, containers, databases, load balancers, storage, notification, and queue services, along with the accounting service called as AWS Billing. Now let me go to the console to show you how you can add an AWS service and monitor it. So go to New Monitor and add New Monitor. And under Cloud Apps, you'll be able to see Amazon. Click on Amazon and you will see this window. Give a display name and click on the services that you do not wish to monitor and remove it. Specify the access key ID and the secret access key. So when you click on any one of these account types, which is in accordance with your AWS account, you can see that the regions will change accordingly. You can also choose whether or not you want to discover and manage the child monitors. And you can make advanced settings such as action on deleted resources, regex to filter the EC2 instances. And if you want to stop discovering the child monitors, you can simply do it. And you have to specify the polling interval. After that, you can add the monitor. So you can also choose how you want to collect the data. Go to admin and performance polling. Under performance polling, you will be able to view this window and click on Amazon. When you click on Amazon, you can choose whether or not you want to specify the EC2 instance by the instance ID or the tag name, or you can choose whether you want to collect the S3 storage statistics via the CloudWatch API, or if you want to enable the auto scaling alerts for EC2 instances and set the health severity as critical or warning based on the created instances, deleted instances, or both. You can also optimize the data collection for the AWS services by going to the optimize data collection tab, and under the monitor type, just choose Amazon or Elastic Kubernetes service or Elastic Beanstalk. Now let me show you the KPIs that you can monitor. Go to monitors, and under cloud apps, you will be able to view Amazon. Click on Amazon and you will see a window such as this. In the overview tab, it will give you a general rundown of all the resources that you have provisioned. And the main service details are provided in the other tabs, such as compute, containers, database, ELB, S3, SNS, SQS, and billing. So other than S3, SNS, SQS, and billing, you will only be able to view the summary of all the services under the tabs. So if you want granular data, you will need to click on the instances or the services that have been entered. So clicking on an entry, you will be able to view the underlying data. For EC2 instances, you can see the overview tab, which provides a general server snapshot of the instance. Here you can monitor the CPU utilization, network traffic, and disk I/O. So in order to view the OS level metrics, you need to make sure that the CloudWatch agent is already deployed in the EC2 instance. Otherwise, you won't be able to view the OS level metrics in Applications Manager. You can also view the metrics related to attached volume, wherein you can monitor the volume versus idle time, volume versus read-write latency, volume versus read-write bandwidth, and volume versus read-write throughput. Moving on to the Lambda function, by clicking on the entry, you will be able to view the granular data. And here you can monitor the invocations along with the actual throttled and failed invocation. You can also monitor the concurrent executions, duration for the execution, and async delivery rates. So moving on to Elastic Beanstalk environment. Under Elastic Beanstalk environment, you will be able to view the overview of the instance, wherein you can see the instances which are okay, which have been degraded, which are severe, and etc. Also the inventory details. Under performance, you will be able to view the server snapshot of the instance, wherein you can monitor the resource usage details along with the network details. You can also view the request details, wherein you can see the total requests, the response summary, the error responses, etc. And in latency, you can monitor the application latency and the top 5 instances based on latency as well. In instances, you can view the usage details, the resource usage details of the instances. Moving on to containers, you can monitor 2 types of containers. One is the Elastic Container Service, and the other one is the Elastic Kubernetes Service. By clicking on any one of the entries in Elastic Kubernetes Container Service, you'll be able to view the overview of the container. So this Elastic Container Service is integrated tightly with EC2 and Fargate instances. So you will have to monitor these as well. So in the overview tab, you can view the pending and running EC2 tasks along with the running and pending Fargate tasks, and also the EC2 active and draining EC2 services, active and Fargate services as well. So the cluster performance tab provides you the resource usage of the cluster, and a resource shortage will most definitely impact the cluster performance. So the important metrics that you need to monitor here are the running status of tasks and the desired tasks, which are here. So the running versus pending versus desired tasks in both services and container instances. You can also view the server in service insights such as the memory utilized, storage read-write rate, and storage data transmit rate as well. Under container instances, you will be able to view the resource usage of the container instances along with the running tasks versus pending tasks. So moving on to the Elastic Kubernetes service, similar to the Kubernetes monitor, you'll be able to monitor the nodes, pods, services, persistent volume, and service map. Under the overview, you have the cluster information along with the namespace information. In node, you will be able to view the top 5 nodes by memory and CPU. And in pod, you'll be able to view the pod details along with the status of the pods. In services, you have the deployment details as well. And in persistent volume, you can monitor the persistent volume and persistent volume claim details. The service map is a graphical map view containing the namespace and service details. So in database, you will be able to monitor relational database and Dynamo database. In relational database, you can monitor both Aurora DB and a normal relational database. In relational database, the important metrics that you need to monitor are the metrics related to disk I/O and network, wherein you will be monitoring all the resource usage details like CPU utilization, storage details, database connections, etc. And in disk I/O, you will be viewing the I/O throughput, I/O latency operations. And in network, you can monitor the network traffic. In DynamoDB, the metrics that you can monitor are the read-write metrics, table errors, global secondary index, and streams. So under table errors, you will be able to view all the user errors, system errors, the conditional check failed requests, or the time to live deleted item. And in global secondary index, you need to monitor the read capacity units, write capacity units, along with the throttled events in both read and write. And also you can see the online index consumed read-write capacity. In streams, you can view the request latency, returned bytes and returned records count, and also the configuration of the stream. Moving on to Elastic Balancers, you can monitor both application load balancers and network load balancers. The metrics listed under the load balancers are same for both network load balancers and application load balancers. In application load balancers, the overview tab provides a general overview and provides you with the average latency and requests and also the connection. In targets, in the errors, you can see all the errors that have been caused. And here the important metrics that you need to monitor are the healthy and unhealthy hosts in the target groups. So you can also measure the average target latency and also the requests per target. And under targets, you can monitor the status of the targets. Moving on to S3 buckets, it provides you with the whole summary of the storage statistics. Here you can monitor the latency of the requests in the bucket, along with the bytes downloaded and uploaded, client and server errors. So moving on to the notification service, you have a general overview over here, wherein you can monitor the SNS usage, along with the total messages published, delivered, and failed, the message throughput, the delivery rate, and failure rate. You also have the region-wise metrics in both graphical and tabular format. And in SQS, the important metrics that you need to monitor here are the arrival rate versus the completion rate. In AWS billing, you can view the total expenditure and forecast for the month and also forecast for the current month. So as you can see here, the month-to-date expenditure is given as $152, and the forecast has already been predicted as $210. You can also view the division or the split up of all the taxes and services levied on your expenditure, and also the month-to-date top services by spend and month-to-date spend by service. That is it about Amazon Web Services. Moving on to Azure. So these are the Azure services monitored in Applications Manager. So you have the virtual machines, Azure service buses, SQL databases, and storage accounts. So Applications Manager collects all the data with the help of Azure SDK in the form of metrics and events and provides you with a unified view on Applications Manager. We'll take a look at how you can add a monitor and monitor all the metrics in Azure on the console. To add a monitor, go to Add New Monitor, and under Cloud, you have the Microsoft Azure service listed. Specify a display name, specify your subscription ID, and remove any service that you do not wish to monitor. You need to specify the discovery mode as well. If you choose the AD application and service principal, you need to specify the client ID, tenant ID, and application key. If you choose to choose the Azure organizational account, you need to specify the user email and password associated with your Azure account. If you wish to choose the OAuth discovery mode, you need to specify the OAuth provider, specify your timeout and polling interval, and add the monitor. So the monitor will be added now. Let's go to the monitor to check the KPIs that you can monitor with Applications Manager. Click on Azure under Cloud Apps, and the Overview tab provides you with a general overview of the resources that you have provisioned in your Azure account. Under virtual machines, you will have a general summary, and the metrics that you can monitor and you need to monitor are the metrics related to the resource usage. You can monitor your CPU, memory, and disk and network usage in your Azure VMs. And under disk, you can also view the read-write throughput, read I/O ops, and disk I/O latency, and also the disk spacing of the Azure VMs. In storage accounts, you have both a standard storage accounts and premium storage accounts, which you can monitor with Applications Manager. When you open the entry, you'll be able to view the overview where you can see the availability of the storage services, where you have the blob, table, queue, and file availability, and also the configuration details. You can monitor the capacity, throughput, latency, and the requests failed details for all the blobs, tables, files, and queues as well. For the requests failed, you have a subdivision of all the errors which are causing the requests to fail, like throttling errors, timeout errors, other client errors, other server errors, authorization errors, network errors, and successful requests. Moving on to Azure SQL databases. As with any SQL database, the important metrics are the metrics related to the queries. So even here, you can monitor the top queries by CPU, top queries by I/O, the top CLR queries and wait, top slow running queries, frequently executed queries, and most blocked queries. So by monitoring the slow running queries and the most blocked queries, you will be able to know which query is causing the application to slow down. When you know the query, you can make a decision whether or not you want to purge the query or you want to keep it running. So Applications Manager will identify the queries which are causing the application to slow down. So moving on, we have the Azure Service Bus. And under Azure Service Bus, you can monitor the metrics related to the queues and topics. So under queues, you can also see the active queues based on incoming requests and based on messages. And under topics, you have the same based on incoming requests and messages. And also you can see the underlying data such as incoming requests, successful requests, throttle requests, etc. So that is it about Microsoft Azure Monitoring with Applications Manager. Moving on to part 2 of today's session, how to gain insight into the performance of your Kubernetes clusters by monitoring your nodes, pods, and containers. So as you know, Kubernetes is an open source container orchestration platform for automating deployment, scaling, and management of application containers across clusters of hosts. It's becoming the de facto compute control plane for not only cloud native, but also for on-premises apps as well. It offers a built-in implementation for both internal, which is the east-west traffic, and external, which is the north-south traffic load balancing. A typical Kubernetes architecture consists of multiple clusters, and the cluster consists of worker machines called nodes, which has the containerized apps. Each cluster has at least one node, and the nodes host pods which contain one or more containers which share the same resources. A persistent volume is a storage element provisioned by an admin or is dynamically provisioned using storage classes. And a service is an abstract way to expose an app running on a set of pods and is responsible for enabling network access to a set of pods. You also have a deployment, which is responsible for keeping a set of pods running. And we'll look at all the KPIs you can monitor in Kubernetes. So with the help of Applications Manager, you can monitor all the KPIs related to nodes, pods, clusters, containers, deployment details, persistent volume and persistent volume claims, and services. Let me go to the console to show you how you can add a Kubernetes monitor. Go to New Monitor and add New Monitor. And under Virtualization, you will be able to view Kubernetes. By clicking on it, you will see this window. Give the display name, the cluster host name, and the IP address, along with the credential details, where if you want to use the below credential or if you want to select from a credential list. If you choose the select from credential list, you have the credential manager, the SSH port, and if you choose the use below credential, you can choose whether or not to enable the public key authentication. If you choose the public key authentication, you need to specify a passphrase as well, along with the username, private key, and prompt. You can also monitor specific namespaces based on filter conditions, whether or not to include the namespaces. Specify the timeout interval and the polling interval. And if you want to test the credential, which you just mentioned here, you can test it. And after that, you can add the monitor. So what are the KPIs that you can monitor in Kubernetes? So in Kubernetes, as I mentioned before, you need to monitor the nodes, pods, and services. And in the overview tab, you have the namespace details, a general overview of the pods and the nodes, along with the cluster usage details and the component details. So under nodes, you can monitor the resource usage of the nodes, the allocatable memory, memory limit, memory request percentage, etc. You can also view the node pod details and other node details. So here you can see the used pod count and allocatable pod count. These are important metrics. So if you can check whether your nodes are being under provisioned or over provisioned over here. And under pods, you can see the pod details. The important metric that you need to monitor is the pod status. You need to monitor whether it's running or not. And under services, you can monitor the service type protocol like general service detail along with the deployment details. And in persistent volumes, you can monitor the persistent volume details and the persistent volume claim details, their status as well. So that's it about the Kubernetes monitor. Moving on to third part of the session, how to detect service outages application lags, server downtime, and other bottlenecks inside and outside your cloud environment. So in order to prevent service outages, you can create and associate threshold profiles to the important KPIs that you want to monitor and you want to be alerted for. And you can also trigger automated actions to be performed upon breaches. So let me show you how you can do that. So you have a tab here called as threshold profile. Click on new threshold profile and you can create a new threshold profile for any KPI. So you can specify the critical severity and also the baseline for warning and clear severity. And an adaptive profile, which is basically adaptive threshold profile, you can base it on the baseline values, wherein you can base the baseline values on the previous week report data, or you can choose any other week that you wish to. You can also check to specify the baseline as a percentage, and you can give the same for all the severities. And you also have the anomaly profile, wherein you can identify the performance degradation of your services or your monitors. So in anomaly profile, you need to specify the anomaly profile name. You can choose whether or not to use the baseline values, or if you want to use a custom expression. And baseline values, you have a fixed baseline where it is based on a week of a month. So here you have the week 1 of February 2022. You can also choose the moving baseline value, which is based on the previous week's report data. And also you have to specify the values as percentage of the baseline, which is specified here. You can also compare the last hour's value directly with the baseline value, or you can compare the values based on the corresponding difference with the previous hour. So when you configure all these threshold, adaptive profile, and anomaly profiles and associate them with KPIs, alarms will be generated. So as for the alarms, you can also configure actions and associate it with the threshold profiles. So these are the actions that you can associate through the threshold profiles. Since we are talking about the cloud today, I'll show you how to create an action for cloud. So under cloud action, you have to select the monitor type, whether it's Azure or Amazon. For Amazon, you can start, stop, or restart instances if the threshold values are breached. And in Azure, you can start, stop, and restart the VMs. So that's how you prevent the service outages. So you can also generate alarms, like I said. When an alarm is generated, this is how it appears. And based on the threshold and anomalies profiles associated to the KPIs, these alarms are generated. These can be escalated via email and SMS also. So let me show you how it looks on the console. So in the Amazon, the health of the Amazon monitor was critical. So if you want to check the root cause analysis, you'll also be able to view it. Like Applications Manager automatically gives you the root cause of the issue. So the health of Amazon is critical because of this instance, my first ALB for testing, which is listed under Elastic Load Balancers. So you can use the anomaly dashboard to troubleshoot. This is about the root cause analyzer. And when the health of a service is critical, an alarm is generated. So you can also analyze the application lags with the help of APM Insight Agent, which was talked about in part 2 of this series. So if you wish to revisit that part, you can do that by visiting our YouTube channel or our website. And how do you prevent the server downtime? As you know, Applications Manager monitors various types of servers, databases, service apps, etc., along with the cloud elements. And you can map the dependencies between the cloud and the non-cloud elements and also the applications that are dependent on both cloud and non-cloud elements. By mapping these dependencies, you will be able to get deeper visibility into those elements. And when you monitor these in synergy with your cloud services, you can achieve an all-around high performance across your IT infrastructure. By using the threshold and anomaly profiles, you may be able to preempt any issues that may result in unresponsive service or cloud services. And you can also anticipate the resource usage and growth with forecast and capacity planning reports and make educated decisions regarding right sizing your servers. So moving on to the final and the fourth part of today's session, how to track the performance of your Microsoft Teams application. As you know, Microsoft Teams is a proprietary business communication platform developed by Microsoft as part of the Microsoft 365 family of products. It enables you to chat, call, share your files, and store files. You can perform video conferencing and voice conferencing, and it also easily integrates with other applications in the Microsoft 365 family of products. What can you monitor with Applications Manager? You can monitor the service health, the team stats and details, the channel stats and details, the usage, activity, and issues. So I'll show you how you can add a Microsoft Teams monitor. Go to new monitor and add new monitor. And under cloud apps, you have Microsoft 365. Since it's a part of Microsoft 365, you'll be able to add the service here. Specify the display name, the tenant name, and user email, password. Unlike Azure and Amazon services, where you had to remove the services that you didn't want to monitor, you need to choose the services that you need to monitor in Microsoft 365. So click on Microsoft Teams, and if you want to monitor the Microsoft Teams, you need to enable the service health monitoring as well. When you enable the service health monitoring, you need to specify the tenant ID, and client secret. Specify the timeout and the polling interval, and you're good to go. Let's take a look at this KPIs monitored in Microsoft Teams. Go to Microsoft Teams under Cloud Apps. And when you click on the Microsoft Teams, you will have an overview wherein you have the Microsoft Teams service health. And you also have the status of the health. So the status of the health can be anything, and it has 18 possible statuses like restored, not restored, operating, or degrading. And if your status is degrading, issues will be generated, and you can view the issue details as well. And you have the endpoint connectivity details where you need to monitor the response time of the endpoints and the status as well. So under teams and channels, you will be able to view the underlying operations like the channel count or the member count and the member count in each channel, along with the health of the channels and teams. And the usage, you will be able to view the number of users based on the device type per day and in the last 30 days. User count based on activity, where you can monitor the team chat messages, private messages, calls, and meetings. And in the number of users based on the device type, you can monitor the number of users who are using the web to access Microsoft Teams, whether they're using the Microsoft Windows Phone, Android phone, iOS, Mac, or Windows. So that is it about Microsoft Teams. This is how the issue details are shown in the console. Since all the services were operational or restored, you won't be able to see it in the console. So since the service is degrading over here, you have the issue status, issue type, issue origin, and the description of the issue, along with the time which has been occurred since the issue. So that is it for today. So let's take a quick recap. So we saw how you can proactively monitor your AWS and Azure infrastructure and all the important KPIs that you can monitor in your Azure and AWS platforms. So in the second part, we saw how you can monitor the KPIs like node details, pod details, containers details, persistent volume details, etc. in your Kubernetes container orchestration platform. We saw how you can detect, troubleshoot, and resolve the anomalies and all the other issues inside and outside your cloud environment. And we also saw how you can track the MS Teams accounts and usage. Thank you all for tuning into today's session and staying till the end. I hope you all have a good day. Until next time, this is Angie. Goodbye.